The Sukhoi Su-35, Russian Sukhoi 35, NATO reporting name Flanker EM, is the designation for two improved derivatives of the Su-27 air defense fighter. They are single-seat, twin-engine, super-maneuverable air superiority fighters, designed by the Sukhoi Design Bureau and built by Sukhoi. The type was originally developed by the Soviet Union from the Su-27 and was known as the Su-27M. It incorporated canards and a multifunction radar, giving it multi-role capabilities. The first prototype made its maiden flight in June 1988. Following the dissolution of the Soviet Union, Sukhoi redesignated it as the Su-35 to attract export orders. 14 aircraft were produced and used for tests and demonstrations. One example had thrust vectoring engines and was in turn redesignated the Su-37. A Seoul Su-35UB two-seat trainer was also built in the late 1990s that resembled the Su-30MK family. In 2003, Sukhoi embarked on a second deep modernization of the Su-27 to serve as an interim export aircraft awaiting the development of the Sukhoi PAK-FE Su-57 program. Also known as the Su-35, this version incorporates technology from the PAK-FE program and has a redesigned cockpit and weapons control system and features thrust vectoring engines in place of the canards. The type made its first flight in February 2008. Although it was designed for export, the Russian Air Force became the launch customer in 2009, with the production version designated Su-35S. China's People's Liberation Army Air Force has also placed orders. With the need to update Russia's aging fleet of Su-27 aircraft, Sukhoi and NAO in 2002 started integrating glass cockpits and improved weapons control systems to accommodate a greater variety of weapons to existing Air Force aircraft. The Su-27SM, as the modified aircraft is called, made its first flight in December 2002. The initial success of this project led Sukhoi in December 2003 to proceed with a follow-up deep modernization program. Known internally as T-10BM, the program was aimed at a more thorough redesign of the airframe to narrow the qualitative gap between Russian aircraft and foreign fourth-generation aircraft. The resultant design, also designated Su-35, would serve as an interim solution pending the introduction of the PAK-A fifth-generation fighter, which eventually became the Su-57, many features of which the aircraft would incorporate. Initially, the aircraft was primarily aimed at the export market, being offered by NHO as a single-seat alternative to the two-seat Su-30MK variants built by Irkutsk Aviation Plant, IAP.
In many respects, the T-10BM design outwardly resembles the Su-27 more than the Su-27M. During tests of the thrust vectoring engines and the Su-27M's aerodynamic layout, Sukhoi had concluded that the loss of maneuverability due to the removal of the canards, the addition of which imposed a weight penalty on the airframe, could be compensated for by the addition of thrust vectoring nozzles. Industry progress in the fields of avionics and radars has also reduced the weight and size of such components, which shifts the center of gravity of an aircraft rearward. Accordingly, we saw SW designers remove the canards and the dorsal air brake found on the Su-27M. The size of the vertical tails, aft cockpit hump and tail boom were also reduced. With such changes, as well as the increased use of aluminium and titanium alloys and composites, designers had reduced the empty weight of the aircraft, while maintaining a similar maximum takeoff weight to the Su-27M. While the Su-27M design had the avionics to give the aircraft the nominal designation as a multi-role fighter, flight tests with the Russian Air Force revealed difficulties in deploying the aircraft's armament efficiently. According to Aviation Week and Space Technology, Air Force pilots described weapons trials with the aircraft in Akhtubinsk and Lipetsk as a negative experience, with a particular emphasis on the layout of the cockpit and its adverse impact on the workload of the single pilot. Designers, test pilots, and avionics software specialists therefore worked together to redesign the cockpit and its attendant systems and improve the human-machine interface. The information management system of aircraft's avionics suite had been changed so that it now has two digital computers which process information from the flight and weapons control systems. The information is then displayed on two 9 inches, 12 inches, 23 centimeters, 30 centimeters multifunction liquid crystal displays, which replace the smaller multifunction cathode ray tube displays found on the Su-27M. The pilot can also view critical flight information on the head-up display and is equipped with hands-on throttle and stick (OTS) controls.
The Su-35 employs the N035 Urbis-E Snow Leopard Passive Electronically Scanned Array (PEAT) radar, which is a further development of the N011M radar that had been evaluated on Su-27M test beds and constitutes the core of the Su-35's weapons control system. It is capable of detecting an aerial target up to 400 kilometers, 250 miles, 220 nautical miles away, and can track 30 airborne targets and engage 8 of them simultaneously. In addition, the multifunction radar is capable of providing high-resolution images of the ground using synthetic aperture mode. The aircraft is equipped with an OLS-35 optoelectronic targeting system ahead of the cockpit to provide other forms of tracking, including infrared search and track. For defenses against enemy tracking, the Su-35 is equipped with the L-175M Kibini-M electronic countermeasure system, while engineers have applied radar-absorbent materials to the engine inlets and front stages of the engine compressor to have the Su-35's frontal radar cross-section and minimize the detection range of enemy radars. The radar cross-section of the Su-35 is reportedly 1 to 3 square meters. The multi-role Su-35 can deploy air-to-air missiles of up to 300 km, 190 miles range, and can carry the heavy Onyx anti-ship cruise missile, as well as a multitude of air-to-ground weaponry. The Su-35 is powered by a pair of Saturn AL-41F1S turbofan engines, formerly known as Isdeli Product 107S, a highly upgraded variant of the AL-31F. The AL-41F1S is closely related to the Su-57's Saturn AL-41F1 Isdeli 117, differing primarily in the engine control system. The engines are equipped with thrust vectoring nozzles, which have their rotational axes canted at an angle. The nozzles operate in one plane for pitch, but the canting allows the aircraft to produce both roll and yaw by vectoring each engine nozzle differently. This configuration was first implemented on the Su-30 MKI and is also used on the Su-57. The Su-35's thrust vectoring system and integrated flight and propulsion control systems allow the aircraft to attain 9G maneuvers and super maneuverability, enabling it to perform post-stall maneuvers at low speeds. This differs from Western air combat doctrine, which emphasizes the maintenance of a fighter aircraft's kinetic energy. The engine gives the Su-35 the limited ability to sustain supersonic speed above Mach 1.1 without the use of afterburners, also known as supercruise.
In January 2016, Russia made the first combat deployment of the Su-35S when it sent 4 aircraft to Syria. This occurred following the increased tensions between Russia and Turkey as a result of reported incursions by Russian aircraft into the Turkish airspace and the shooting down of a Russian Su-24 bomber by a Turkish F-16 fighter in November 2015. Its combat deployment to Syria helped to find and subsequently resolve a number of problems, for example with the aircraft avionics. Su-35s in Syria have been seen carrying unguided bombs, with Russian sources claiming that the Su-35 has carried out strikes against ground targets using guided weapons. On the 20th of August 2019, 2 Russian Aerospace Forces Su-35Ss, operating from the Kmamim Air Base, intercepted 2 Turkish Air Force F-16s over the southern Idlib and forced them to leave the Syrian airspace. Russian Su-35Ss again intercepted several Israeli aircraft over southern Syria on the 10th of September 2019 and prevented them from carrying out airstrikes. Another interception allegedly occurred on 19th of September 2019 when 2 Russian Su-35Ss intercepted Israeli aircraft preparing to attack suburbs of Damascus. On the 15th of October 2019, a Turkish F-16 fighter was intercepted by Russian Su-35S and forced to retreat as it was attempting to bomb the Syrian Democratic Forces headquarters in Manbij. On the 12th of November 2019, Russian Su-35Ss intercepted an Israeli fighter during airstrikes on Damascus. On the 7th of December 2019, several Israeli aircraft were intercepted by Russian Su-35 SS and forced to retreat during an attempt to bomb the T-4 airbase. India has been reluctant to order the Sukhoi HAL FGFA due to high cost, and it has been reported that India and Russia are studying an upgrade to the Su-35 with stealth technology similar to the F-15 Silent Eagle as a more affordable alternative to the FGFA Su-57. The aircraft is competing with 7 other aircraft in a fresh tender, which is referred as MMRCA 2.0 in the Indian media, for the procurement of 114 multi-role combat aircraft.